Welcome to the channel, Automotive Guru here. Consider subscribing the channel and hit the notification bell for more videos. Today we are going to discuss exhaust gas recirculation system, working principle, design and benefit. The main function of an exhaust gas recirculation system is to remember we are moving into where we have controlled emissions in some countries where we are more concerned about the environmental effects of the emissions we put into the air we breathe. Well, introduction. Diesel engines tend to emit higher nitrogen oxide, which is harmful to human beings. This is because high temperatures in the engine cylinders because of higher compression ratio. To control or reduce nitrogen oxide, manufacturers employ exhaust gas recirculation technology in engine. The term EGCR stands for exhaust gas recirculation. It is part of a modern-day diesel engine vehicles which help to decrease nitrogen oxide emissions. Exhaust gas recirculation is a technique used for reducing the nitrogen oxide in both the internal combustion diesel engine as well as petrol engine. Working principle. The exhaust gases added to the fuel, oxygen and combustion product increase the specific heat of cylinder contents, which lowers the ambient flame temperature. In typical spark ignited engine SI, 5% to 15% of exhaust gases is routed back to the intake of the EGCR. The maximum quantity is limited by the need of the mixture to sustain a continuous flame front during the combustion event. Excessive EGCR in poorly set up application can cause misfires and partial burns. Although EGCR does measurably slow combustion, this can be largely compensated for by advancing spark timing. The importance of EGCR on engine efficiency largely depends on the specific engine design and sometimes leads to compromise between efficiency and nitrogen oxide emissions. A properly operating EGCR can theoretically increase efficiency of gasoline engine via several mechanisms. Reduction of throttle losses. The addition of inert exhaust gases into the intake system means that for a given power output, the throttle plate must be opened further, resulting in increased inlet manifold pressure and reducing throttle losses. Reduced heat reduction. Lowered peak combustion temperatures not only reduces nitrogen oxide formation, it also reduces loss of thermal energy to combustion chamber surfaces, leaving more available for conversion to mechanical work during expansion stroke. Well, I'll name reduced chemical dissociation. We'll work on that by clearly trying to Google what is reduced chemical dissociation. We'll talk about the design. A vacuum control EGCR valve regulates the amount of gases admitted into the cylinder. This consists of a spring-loaded vacuum diaphragm It links to the metered valves which control the passage of the exhaust gases. Ported vacuum from the calibrated signal port located above the throttle valve connects the Egr vacuum chamber. At idling, the Egr valve is in closed position because of the spring pressure and lower ported vacuum. The engineers designed it so because if the exhaust gases recirculate at the idling, then it will cause rough or erratic idling. Upon opening of the throttle, applies the ported vacuum and gradually opens the tapered valve. This causes the exhaust gases to flow into the intake manifold. However, when the throttle opens fully, there is no vacuum in the intake manifold, so it closes the tapered valve and stops the exhaust gases from entering the intake manifold. Benefits. The exhaust gases recirculation system recirculates a part of exhaust gas back into the engine cylinders through the combustion chamber. The logic behind the Egr system is simple. The exhaust gases is hotter than the fresh air sucked by the engine, so the exhaust gases significantly reduces the content of the cylinder for combustion. Because of absence of O2, the exhaust gases have nothing to burn, as they contain neither fuel nor oxygen particles. Thus, it results to lower heat discharge and cylinder temperatures. It reduces the formation of the nitrogen oxide as well. The dormant exhaust gas present in the cylinder limits the peak temperature. It also reduces the loss that rises because of throttle in petrol engines, while improving the engine life by reducing the cylinder temperature. Limitation. The engineers designed the Egr system in such a way that it recirculates the exhaust gases only when the engine forms nitrogen oxide. Thus, the Egr system does not affect the full load operation. The exhaust gas circulation system also has a thermal control valve in the vacuum line, which prevents the operation of Egr at lower engine temperatures.